Dear students, in this video we are going to see about the principle of operation of various methods used for the measurement of high voltage AC and impulse and circuit operation, comparative study, and then advantages and limitations of the methods. What are the various methods involved for the high voltage AC measurements? We will see one by one. First one is RMS value measurements, second one is power frequency peak value measurements, and third one is impulse and high frequency AC measurements. So first one is RMS value measurements. Series impedance voltmeter, potential dividers, potential transformers, or electrostatic voltmeters with special consideration to insulation level and source loading is called as RMS value measurements. That is series impedance voltmeter, they are coming under these RMS value measurements. Series impedance voltmeter, potential divider, potential transformer, or electrostatic voltmeters with special considerations to insulation level and source loading. Since we are measuring high voltage, we have to consider the value of insulation level and source loading. Then the second method is power frequency peak value measurement. Power frequency peak value measurements, in which we are going to use peak voltmeter and spear gap for measuring the peak values of the AC voltage, that is the impulse voltage or AC voltage. Then finally, impulse and high frequency AC measurements by potential divider with the CRO for recording the voltage waveform. We will see one by one. First one is the RMS value measurement, that is the potential transformer method using magnetic type. Figure shows the magnetic type potential transformer. See the diagram. The first one is the potential transformer, in which we are measuring the value of kilovolt, and there will be a gap, spear gap is used, then there will be a test object. So the diagram shows the potential transformer magnetic type. This diagram shows the potential transformer used in earlier methods in cascade transformers. See the diagram, that will be a potential transformer which is used in cascade with the transformers. Let us see the circuit operation. The magnetic potential transformers are simple in construction and represents the oldest methods for AC measurement. It is the oldest method for AC measurement. For very high voltages, cascading of transformer is used. The potential transformer doesn't permit the fast rising transients or high frequency voltage along with normal supply frequency voltages. Hence, measurements are unaffected by harmonics. Very high voltage cascading of transformer is used. The potential transformer doesn't permit fast rising transients or high frequency voltage along with normal supply frequency voltage. Hence, measurements are unaffected by harmonics. So, we are going for the potential transformer method with test objects like insulators, cables, etc., which are capacitive in nature. A voltage rise occurs with the testing transformer and the potential transformer winding gives value less than the actual applied to the test object. With the test objects like insulators, cables, which are capacitive in nature, so the symbol is represented by capacitor. A voltage rise occurs with the testing transformer and the potential transformer winding gives value less than the actual applied to the test object. So it need a voltage correction. So a voltage correction is applied based on the ratio of load capacitance and test object capacitance. So we request voltage correction. It is applied based on the ratio of load capacitance and test object capacitance. See the advantages. It is simple in construction. Measurements are unaffected by harmonics. For testing with high voltage, testing transformer, separate potential transformer is not required. A territory winding of transformer acts as potential transformer for the measurement. These are the advantages of this method. For testing with high voltage testing transformer, separate potential transformer is not required. A territory winding of transformer acts as the potential transformer for the measurement of high AC voltage. But it is the oldest method for the measurement of AC voltage. The limitations of these methods are: for capacitive test objects, the voltage measurement is inaccurate. For capacitive test objects, the voltage measurement is inaccurate. Ratio and phase angle errors are caused due to magnetizing and leakage inductance of testing transformer. Ratio and phase angle errors are caused due to magnetizing and leakage inductance of testing transformer. Then method 2 is series impedance voltmeter. The diagram shows the series impedance voltmeter. The red color symbol shows the series impedance voltmeter method. Let us see the circuit operation for series impedance voltmeter. Series impedance voltmeter is used for power frequency AC measurements. High resistance units for high voltages have stray inductance and capacitance. The first figure shows the stray inductance equivalent circuit and the last figure shows the stray capacitance equivalent circuit and can be represented by an equivalent circuit having lumped parameters. They are represented in the figure. This equivalent circuit is not valid for large dimension resistors. The resistor has to be approximated as a series elemental resistors. The equivalent circuit with guard ring and compensated resistors helps in removing the stray inductance. The stray ground capacitance can be removed by shielding the resistor by a second surrounding spiral resistance that shunts the actual resistor but does not contribute to the current. The figure, the center figure shows the lumped equivalent circuit with resistance, inductance and capacitance. It is having high value of resistance. The first figure shows the equivalent without stray inductance. So by using guard ring and stray capacitance, it can be removed. And the last figure shows the equivalent circuit with without stray capacitance. The resistance Rg is the guard ring capacitance and the insulated resistance is represented by Ri. They are shielded by the high resistance. The limitations of this circuit is given by resistances causes power dissipation. We already know. Resistances are sensitive to temperature. High resistance carries stray inductance causing higher impedance. High resistances carries stray capacitance. These are the limitations of this circuit. Let us see the third method, which is called as series capacitance voltmeter. The diagram shows the series capacitance voltmeter. It is actually like the series impedance micro ohm ammeter. Instead of series resistance, we are going for the capacitance. All the others are the same as per the series micro ohm ammeter. Let us see the circuit operation. To avoid the drawbacks associated with resistance, a series capacitance can be used instead of resistor. The method does not take care of temperature variation and power dissipation, but the error in measurement results if the harmonics are present in voltage. For example, if fifth harmonic of 10% is present in voltage, then 11.2% error in voltage measurement will result. This method is suitable only for pure sine wave voltage measurements, hence cannot be used if small amount of harmonics are present. Series capacitance is formed as parallel plate capacitor with high voltage transformer terminal and ground plate suspended above it. A rectifier ammeter is used in the range of 0 to 100 microampere. Let us see the summary of three methods. Potential transformer method is simple yet very effective against presence of harmonics. And second method is series impedance method. Use large resistance in series with microammeter, but power dissipation, stray inductance and stray capacitance affects measurements. And finally, series capacitance method can be used for pure sine wave based measurements.